So as I said, this is the process for the assignment. So you should try the CityView AI demo. You should sketch a new user interface, create a visual prototype using something like PowerPoint, so you can make it. PowerPoint allows you to overlay buttons on the screen, things like that. And then the next step is to create a wireframe. And if you want to, you can use a tool like Visio, which lets you lay out graphs, or you can just do it manually and just take a bunch of screenshot snapshots and put them together. And then finally, create an interactive prototype using Azure or Podoco or App Inventor as well as another option for interactive prototype. It's a very easy tool for Android. Just to give you a bit more detail, the idea also is the requirements basically, and I'll put this on the website, is to improve the existing interface. So to look at the visual affordances that we have and the easy views to see if you can improve it, and also to add some new features. So the features to add are, first of all, being able to view multiple options of the same building. So we want to think about how in the future we could use the same tool for viewing alternative designs of the city. So when you go to a city site, right now, when you go take CityView AR outdoors, you see one building on site because that's the building that used to be there. But what we'd like to do in the future is look at several possible designs of the building on the site, because it might be that an architect has produced 3 or 4 designs. So we're going to cycle through those designs. You also want to go further back. Yeah, well, that's the third point with the timeline feature. Yeah. So the second thing is to be able to add comments on the building. So you can imagine an end user using this on the street and seeing a building and being able to add somehow comments on the building in some ways. And the third is to add a timeline feature, which you were just talking about. So being able to go back and forward in time to see historical content as well. So those are the 3 new features to add. They could be added either to existing screens or views we've got, or you could think about adding a new interface piece. So just to be more specific, these are the deliverables that will, for next Friday, is an interface sketches, some visual prototypes, so PowerPoint screens or some other images, a wireframe flow diagram, and then finally a working prototype. So as an example, here's some interface sketches, and here is a wireframe flow diagram. So this is what I showed last week in class with the Bollywood application for the Palm Pilot. So basically, they've taken a bunch of screens, and the wireframe for this won't be as complicated because there's only really 5 or 6 screens currently. So they've taken a bunch of screens, and they show what happens when you hit different buttons. So if you click this button, it says now, it's hard to read that, but it says now we go to picture 24, I think it says, or maybe 11, I can't quite read. So then it jumps across to here, or to image 24, and it says, and if I click this one, it goes to this screen. If I click this one, it goes to this screen. Click this one, it goes to this screen. So it's just basically, you just take the visual prototype you did before in PowerPoint, you make a bunch of screen captures and then string them all together with arrows showing what the interaction flow is about. And then the last piece is here's the PowerPoint prototypes. So you could do something like this, and then you've got the wireframing tools. And here's a list of some tools you could use. One tool I was playing with a bit before was Wireframe Sketcher. And the reason why this might be interesting is because I can put up their website. They have some nice tools on their website for, gosh, got too much stuff going on here.
So there seems to be 2 ways of referring to wireframes. One of them is looking at the flow of interaction, and the other one is actually having an interactive model of it, right?
No, I would say the wireframe just refers to the flow. At least that's my thinking. Maybe in the literature other people refer to it different ways, but yeah. So let me see here. No, it's not there. I was going to show you the website because it's an actually useful tools on the website. So let's go back and we'll grab the website. Looks like I've got too much going on here.
But the thing that we produce here with the wireframing tool will be the final part.
No, the final part will be the prototype. So, sorry. Oh, I see what you mean by wireframing. So yeah. I guess what I mean. So, sorry about that. Yeah, so I should have called this prototyping tools, not wireframing tools. Yeah. It is a little bit confusing because so wireframe sketcher, for example, what they refer to is they want to build something like this, but it actually has behavior. So if I go to the website, it could be useful for you because it also has on the website a lot of templates that you can use that have visual elements in it. So let me just grab so this is their website here, and they've got these. If you go to the mock-up galleries, you can download different stencil, and these are SVG images. So if you wanted to have an iPad bezel, you can grab it from the website. Or if you want to have some different menus for Android or whatever, you can snap from the website as well. So that might help you with your laying out of stuff. There's a bunch of dialogues, there's a bunch of other miscellaneous widgets and things like that. Yeah, and the Wireframe Sketcher tool itself is potentially useful anyway. So I've installed that here. And so this is it here. So you can basically download it and you can run it, and then this lets you grab and move different things around on the screen. You can create multiple screens. You can jump between. You can add sketched arrows and all that type of stuff. So it's pretty easy to manipulate and move stuff around. So I guess you said you tried already using the Azure and you found it a little bit complicated to use.
Well, I don't know. I'm not sure if I was thinking about it in the right way.
Sure. Yeah.
I did find it a little bit complicated.
Yeah. So this lets you make basically a storyboard, and then you can go between the screens, and then you can actually publish it to HTML. So you can click then, and when it's published HTML, you can click between the screens as well.
So those buttons aren't going to do anything, right?
Let me think. Some of them are linked to things. So this one here is linked to the next screen. So some of them are buttons that do things, some don't. So this button here is linked to the previous screen. So you can. So if you, and similarly with these ones here. So this doesn't do anything, but these three with the yellow tabs on, they do things. So for the purposes of the project, you could take some dummy screenshots, or I don't know, like if you wanted to mock up what happens with the panorama, you could take an earthquake image from somewhere, use that as a background, and then put a hotspot on there with one of these buttons on there. And when you click on the image, it goes to somewhere else. So yeah, and then if you publish this to HTML, it produces a website that has that interactive element. So I can click on this, and it goes back to the mock-up screen.
On some of the screens that I'll be doing.
So this is the presentation mode. So if I wanted to present this, I can click here. I can say, okay, now I click on the mock-up, and it goes back to here. Or I can go to the next screen. I can go to the share screen that goes to here. So it becomes a way to mock up a whole interface, basically. And if you wanted to, you could use the Android templates, and you could put this all in a template, and then you could poke different parts of the screen, and you'd go between different templates. Like if I wanted to, if I wanted to have this as the click on this, and it goes to the map view, then you click on that and pop up the map here, and then you could have on the map several icons. You click on one of the icons, and something would happen here, for example. So yeah, it's semi-active. Yeah.
In one of the screens that I'm looking at for sort of the topographical view, if someone clicks on a building, some information displays. Now that's just sort of partially over top of the screen. So do you create a completely separate page for that, or is there a way of like hiding and showing?
I guess it depends on the tool you're using.
Right.
For the purposes of the assignment, it doesn't matter either way, because the idea is that you're supposed to be able to get to the point where an end user can look at it and get the feeling of what it's like to use. And so if you clicked on the image and it swapped a whole new HTML screen, it doesn't matter, or as opposed to having pop up. So it's up to you, really.
I just got a question / potential observation.
Right.
But in terms of like you've got the wireframe tool and then the Podoko.
Well, the Podoko is a form of wireframe tool, so you can choose what tool you want to use.
Oh yeah. So is that the same stage in the process?
Yeah, it's the same. I mean, it's basically. Oh, if I go back to the so basically here. So step 5 is to create an interactive prototype. So you could either use Azure or Podoko or the App Inventor or I guess Wireframe Sketcher, whichever tool you feel most comfortable using and you find it easiest. So the idea is that at the outcome of this, you use step 4. You've got basically a set of screens with arrows drawn between them, showing you what happens when you do different things. And then step 5 is where you make that real. And so the outcome of that is to have something like this presentation, where I can click on things and things happen. And both Podoko and Azure and Wireframe Sketcher and Android App Inventor, they all let you do this. So just pick whichever one you feel most comfortable with. Some have a higher learning curve than others because some provide more professional outcome. The lab has a license for Azure, but we don't have licenses for Podoko and Wireframe Sketcher, but you can use them all on a 30-day free download. So it's all pretty standard. And App Inventor is free.
Okay, so just in terms of, is there, you want to hand in terms of like a PowerPoint?
What I'd like to do is next Friday take some of the lab time and have each of you do a small presentation and show basically here's the so you can hand in, well, you can hand in the sketches, you can hand in the PowerPoint, you can hand in the wireframe, either print it out as an image or just make a digital image, and then you can with these you can Wireframe Sketcher lets you make a web HTML page. You could submit the HTML page, and then what we'll do at the beginning of the lab, we'll take about half an hour, and each person can do a 5 or 10 minute presentation saying this is what I did. Does that make sense?
Yeah.
Okay.
Sorry, I know I'm being
No, that's fine.
troublesome, but
No trouble at all.
if we felt that there was a bit of duplication of work by using separate applications, and we felt that we could achieve, reasonable, satisfactory results just using a single application.
Yeah, but that's fine. I mean, the main. So if you wanted to, for example, you could use the Wireframe Sketcher to produce the visual prototypes. So if you in Wireframe Sketch or Podoko for that matter, or whatever else, they do allow you to lay out visual elements on the screen, so you could use that. And there's probably nothing you can do except for sketching by hand, maybe for the sketch part. And then creating the wireframe is really just a matter of taking screenshots of what you've done for visual prototype and laying them out and drawing the arrows showing how the interactivity. So certainly if there was one tool that lets you do the visual prototype plus the interactivity, it's more no worries at all. The main thing is just to get it. And I guess I talked last week about how, from my perspective, I'm not really concerned about how beautiful the interface looks, as long as it gets the main thing is the interactivity and to show that the interaction flow works. Because normally when you do a project like this, you'll normally get some visual designer to come in and do all the design work anyway. You'll produce a really rough sketch like this one here, and then you'll give it to a visual designer and say, okay, make it look beautiful now, and they'll figure it all out for you. Maybe it could do. So does that clarify about the assignment? And I'm happy to answer more questions next week as well. So on Monday and through next week we can work on it. But yeah, if you haven't already, though, I'd encourage you to go and try the interface. And maybe this weekend, I guess on Saturday and Sunday this weekend, that they're going to open up the Cathedral Square again. And this weekend, next weekend, is the last 2 weekends. I think it's going to be open for a while. And I don't know when they're going to start demolishing the cathedral, but it might be the last chance to see it. So maybe you want to go back again this weekend and take the City View AR and go down to the Cathedral Square, and you can view it there as well.
Is it open already?
No, it's not open. The Cashel Mall is open, but previously they've had a walkway through into the Cathedral Square, and they closed that down after Christmas because they're demolishing a building near there. But then they said that they're going to open the walkway for this weekend and next weekend. So you should try and have a look if you can.
Is it only open during the day, sort of thing?
No idea. I don't imagine it's going to be open after it gets dark, but yeah. But anyway, you should try and have a look if you can. Okay, so that's the assignment. What I want to do is a couple of things today. One is I want to talk a bit about, I have a small presentation that I got from the web about video prototyping. I want to show that briefly and talk through that, because that video prototyping is a really important design tool as well. And then I'm going to talk more about interaction metaphors and hopefully get onto processing, but we might run out of time because of trouble setting up with the thing here. So let's go through that. Okay. So let's see, lots of stuff going on here.
Those are your applications.
Yes. Yeah, it is a lot. Well, I don't need that one anymore. Showing that. That's a video I want to show later. And here's the
You go find a file.
Yeah, I guess so. That's great. Thanks. Weird. Okay. So let me talk about video prototyping. This is a presentation that I stole from somebody else. It's here? No, it's not here. It's on my. It's on here actually. Video storyboarding. Here we go. Great. So I'll put this whole presentation on the class site as well. This is done by this guy called David Schuin from Frog Design. Frog Design is one of the most famous design companies. In fact, they designed the original iPhone case with the and the iPod case for Apple. So they this is a workshop he did, and I'll skip through part of it because it's not relevant. But he talked about video scenarios, and the idea of video scenarios is to use video to and paper to prototype very quickly. And I showed an example of that last week with Bill Buxton, where he had this the post-it notes doing it. I've got a more complicated example here, so I'll show you that video here. And the main point is that by using video, you can prototype very quickly, and it's different from doing just paper prototyping because it has the interaction shown as well. So do this one here. So this is the iPad application, and it's a mind mapping application. So he's doing the man brain, and he's showing how it would work. So you can see with that he's prototyping different ideas. The idea is you can draw a circle with a finger, and it creates the bubble, and then you draw the lines, and it draws things together. And then you can type inside the circle, and it puts up in your keyboard. You can type in what you want to do, and then you can also create new lines and. So it's kind of done like a stop motion video. Delete the taps on it, and it goes bigger, and you can stretch with this finger, it makes it bigger. And you can stretch it and makes it bigger. And maybe he wants to join it, so TV you can just substitute a beer. A beer can be moved around. And anyway, so that's a simple little video. So you can see with the video prototype, he's able to quickly prototype a user experience without having to do a lot of work. I mean, you could make something like that in about 5 minutes probably. There's several styles of video scenarios. One is to do stills with a voiceover. So you can show still photographs as a voiceover as well, or you could do stop motion, and last week we talked stop motion, or you could do a live action video as well. And video is really great because it's a really good way of capturing gesture and showing task flow, and particularly for describing the user experience with technology. So why do you want to use video rather than prototyping? This is an old picture from Mybridge. I think it's Mybridge or Myberg? Mybridge, I think. He's the guy who did amazing stop motion photography about 120 years ago. And he basically proved one of the things he had a bet with one of his buddies that when a horse was running, the horse's legs would be off all four legs would be off the ground at a certain point in time. And his buddy said, no, the horse always had to have one leg on the ground, otherwise it would fall over. And he said, no, I'm sure the horse's legs. So he set up this very elaborate high-speed photography, stop-motion, tripwire setup so he could capture a horse galloping. He proved and won the bet with his friend. But anyway, the main point is that, as we talked before about interaction design, is really about the design of user behavior over time. And because it's designed over time, it's really important to capture that time element, and that's what the video, or show the time element, and that's what video provides to you. So video captures behavior over time. And it also captures what documents describe as well as still images. So it talks about how with video it's easy to capture real context. So when you're trying to use technology in the context, if I'm got my Fitbit here and I'm trying to show how I can use it while I'm running, then video of me running with Fitbit conveys that. It also captures scenario flow, so when you're going through different screens or different applications as well. And it captures gesture affordances too. So here's another video. This is a designer who was trying to design a new type of tangible interface. So his idea was you'd have these real objects, and real objects would do certain things. But he wasn't quite sure of how to convey that to somebody. So he made a video of himself interacting with the objects. And this is the video here. And I won't show the whole thing because it's quite long, but I'll just show the beginning part. So he basically made these clay objects, and the clay objects would be used for different types of input. And the shape of the clay objects did different things, and we'll talk a bit more about that later today, about the notion of affordances. But this object is like a suction cup. This is a cube, so you can turn it to be on different faces. And so the shapes kind of show how they could be used. And you could use several objects together. So he's got this kind of stylus with the suction cup doing something. And I imagine he's imagining he's projecting some image or something on the space while he's doing that. But the main point is that the people watching this can get an idea of the type of gestures that you want to perform. So he did different things with different affordances of the objects. So here's he's using the stylus at the same time. This cube is like a menu selection device, so you can use that at the same time as he is doing the stylus. So it lets him do two-handed input.
Using a corner of the
yeah, and then so anyway, the main point is that you can use video to convey quite rich gestures that you might have in a tangible or gesture in different input devices as well. He's moving rocks around. So.
He's an artist.
He is an artist. He is an artist. So let's get back to where is the.
Probably close the serial file.
Yeah, don't need that. Don't need that. Well, where's my close that down. Close that. We're going to show that one in a minute. Yep. So this is the. And video can also capture the attention of people who want to know what your interface does. So if you make a short, compelling video, you can easily convey what it does. In fact, that's what you guys did for the 3D UI, is that you made a concept video. Well, actually, your video worked for real, but you made a very nice video around your user interface. And it can also be used as a meta for prototyping. Here's a list of potential prototyping options. So you can see with paper, they've made this matrix here that basically talks about what they're good for, how much they cost, and what it's good for doing. And then you can see how it fits in. So paper obviously is free. It's very good for rapid prototyping and early prototyping. It's not so good for digital content because you oftentimes have to sketch on paper and take a photograph of the paper again. It doesn't generate any code, obviously, so that's no good. Whereas if you're doing HTML, you can generate reasonable code. There's Azure here. You can see it's pretty good for most things, but not so good for gestures because with Azure, you don't capture the gesture experience, just capture a set of screens. So what they're saying is that video could fit in here as well with some other prototyping tools too. So video is, in some sense, expressive as paper. In fact, you can draw on paper on the video, so you can show that. But it lets you capture gesture content. It's very good for collaboration and for distribution. You can send around. Again, it doesn't generate code, and to some extent, it's kind of free. You have to have technology, obviously, to make the video.
You know if anyone's looked at using augmented reality to rapid prototyping apps?
Yeah, there is actually. That's a good question. There's a group in Korea that we're looking at building physical prototypes, and then using augmented reality to show screens of the physical prototypes. So you can project onto the prototype. So they're looking at making prototypes of new types of phone devices, so phone form factors, and then you can project onto the phone form factor the image, and I could touch it with my finger and it would come to life. So that's so video is a pretty powerful tool, especially as a gesture input method for prototyping gesture input or for conveying stories. There are some cases when you wouldn't want to use video, and one is that it's not interactive. You know, it's obviously a linear tool. Once you start playing the video, it's very hard to edit and change. It's not real in that the person, the end user, can't actually pick up a device and start doing something with the device because it's just playing a video. It's also can be quite time consuming to make. Although with new tools, it's not actually that time consuming. So, as a simple example, they prototyped had the idea to prototype a teleportation system for easy use in everyday city streets. So, sometime in the future, how would you make a teleportation system? So the basic idea was that you'd walk up to this interface, you'd put in your coordinates, and then you'd step on this thing here, and it would teleport you somewhere else. And of course, with video, you can do that. You could have somebody doing that. You could do a stop motion. Somehow they disappear from the screen. So the basic steps was to break it down to different design processes. So first of all, you have to plan the shoot, then you have to make and set up the shoot the shoot, and then evaluate and edit it. So planning, and here's some things to consider about what you want to plan. Most importantly, probably is a storyboard, and we talked about storyboarding a little bit last week. So here's planning the shoot. So they are planning out the user interface screens that they want to show on the wall there. So they have this logo to start, T, and then you put your hand on it, it recognizes you from handprint, and then it asks you if you want to go to a new location or a previous location. If it says new location, then there's a map, and you can touch the map where you want to go to. And then if it's a previous location, there's a list of locations you've been to before, and you touch one of those, and then you ask you if you're ready to teleport, you hit yes, and then you go and stand on the piece of paper, and it teleports you somewhere. So you can see it's a very simple wireframe interaction flow. And then you plan all the shots, so you build these little storyboard of the shots. So the girl walks up to the transporter, touches the panel to activate, touching each screen in order, so it shows the screens that you've done here before. And then show the girl walking onto the square, countdown, and the girl disappears, poof, and the transporter resets. And then so that's obviously a very easy storyboard you could plan very quickly. There are certain shoots that are quite common where you want to make a close-up of the user interface, over the shoulder, so show somebody seeing the user interface, a medium shot or an establishing shot. And then to plan the shoot, then you should complete a storyboard of every shot. You should build the user interface to everything, and then you should have some sort of hero UI moment for certain critical shots. So when the person is using the user interface to do the transporter, probably what you want to do is you want to zoom in when they start selecting the map location, for example, and then have a zooming out moment where they disappearing, and maybe put the Star Trek effect in where their body turns to pixels and they somehow go away. So here's the typical type of storyboarding tool where you can sketch out the frames here, you can describe the action, you can describe what user interface screens might be required. And then you do the shot, you shoot it, and you edit it, and then that's about it. So that's what I wanted to talk about today, and then he goes on here to actually do a little task that takes an hour to produce the videos. But I guess one thing I want to leave you with is the idea is that in addition to paper prototyping and screen-based prototyping and making wireframes, you should also think about how you can convey what your user interface with a really well-edited creative video. And it needn't necessarily be very complicated to make the video. Or you can either easy by just doing screenshots and a voiceover, you can quite quickly put the video together as well. So that's the first part. The second thing I want to talk about was continuing on from where we left off last week, which is back here. Okay, so I want to talk a bit more about understanding interaction. So last week we talked about prototyping tools, and we talked about how to sketch out different interfaces. We talked about a little bit about history of interface design. What I'm going to talk about now is how to understand interactions. And previously I've shown this sketch from Bill Verplank, where he talked about interaction design is really about asking these three questions. You know, what do you do in the real world, and interact with the real world in some ways. What do you feel? So how does the world respond to your interaction? And then based upon that, what do you know about that interaction? So the main idea is to try and help the user form a mental model. And so what we're going to talk about now is how to form accurate mental models and how important the mental model is. Because that mental model here, or that map, or the path you're forming, is going to form all of your interactions in the real world. So for example, with this Fitbit device, when you look at it, it really doesn't give you much of a clue about how it's used. I mean, it's got a clip here and a one button, and so it's very difficult just looking at that to have a mental model of how to use. But when the company that made that, and I'll show you in a minute, their website, they did a really good job of packaging the technology with the website to tell you how it's used. So one of the most important things is that interaction design is really a process, and it's a process between your ideas here and an actual form that you're trying to create. So whether the form is a set of screens for a user interface, whether it's a physical object, whether it's an interactive space. So there's something along this end here is a prototype or some end technology that the person can use. Here's your idea, and in the middle is a set of metaphors. So the basic idea is to try and build a good metaphor that helps the user understand your mental process, mental ideas.
Is it the user or is it the client?
Well, the client is basically the end user. Yeah. So in order to be able to do that, you need to understand the problem space. You think about what are you trying to create, what are your assumptions, what are your claims, and how will it achieve what you're hoping to do. And so to understand the problem space, you need to analyze existing problem space. And with the assignment, with the CityView AR, you can do this. So you can say, well, what are the problems with the existing CityView AR application? Why do you think they're problems? What do you think? How can you overcome that? And how will your design extend or change the current way of using the technology? So one of the problems, for example, with the CityView AR, you've got it on your phone there, right?
Yeah.
Or I can. Well, why don't you power it up and I can show that. So go to the map view, and then in the map view, touch a building, anyone, doesn't matter. Take a while to get to the map view. Yeah, just the, okay. Just touch one of the buildings, doesn't matter. Anyone. Okay, there we go. Oh. Okay, great. Can you pass me the thing? Okay, so now Rory's just touched the building, and we have this call out appearing that tells you the building name. Now, with the call out, what you can do is you can touch the call out, and it will put more text information up. But if you look at that visually, there's no clue that's really provided back to the end user that they can touch the call out. They just may assume that that's all that does is you touch a building and it provides the name of the building. But so what you want to do is you touch this, and then it will eventually.
Single core.
The responsiveness is something really needs to be worked on.
Yeah, it depends on what type of phone you're running on. And this one's very slow, obviously.
So it seems like a really good point. Like, how do you display that?
Yeah.
This is the thing that you touch.
Well, we'll talk about that a bit later, but that's one of the limitations with this is when you're using it yourself. So, for example, there's a little screen here, and there's an X here. So, from the end user experience, you probably think that if I hit the X, it's going to close that, and I hit the screen here, something's going to happen. And so, in fact, it does. I hit the screen, and this one opens up here.
It's like a design formulation, but cancel or close things within the vicinity of.
Yeah, that's a problem as well, isn't it? Because if I got a fat finger, we're closing there. So for some reason it's not loading up the text, but I guess you've seen it before. So there's a problem with the interface there. So that's one of the things when you analyze the CityView AR, you could see, well, what problems are within the existing interface. So one of the most important things, though, is to build a conceptual model. So the conceptual model is really a high-level description of how the system is organized and how it should operate. And you need to think about how the system appears to the end users. And it's not just a description of the user interface, but it's the structure underlying the user interface. And the benefit basically is that by building a good conceptual model, it enables you to design. It makes it much easier to design forward from there. So as an example, here's the different models that people will form. So there's a system model that talks about how the system works. There's a mental model that is the model that you've got as a designer, and then what you expose to the person is this user interface, the interface model. So one way to do that is to design really good user interface metaphors. And so in many cases, these are designed to be similar to a physical entity that somebody's familiar with, or they exploit the user's familiar knowledge, something they're already using. Or, so for example, in that case, having an X on the corner of that rectangle is people who've used Windows before, or Mac for that matter. They typically they're used to using an X to close down the window. So it conjures up the essence of unfamiliar activity and enables users to more rapidly learn how to use an interface by thinking about their previous knowledge. So as an example, this is an old ledger. I think this is actually from the 1800s. So it's an accounting book where somebody's writing down all of the debits and credits. So on one side is the money taken out, and the other side is money put back in. So it's just a standard ledger book.
Beautiful handwriting.
It is beautiful handwriting, so it must be from a long time ago, I would say. So in the 1980s, when we talked about this last week, one of the big successes was the VisiCalc, which was the first, in fact, killer application. And VisiCalc was designed to build a spreadsheet. And so VisiCalc used the same metaphor. So here the basic metaphor is that it's a book. On one page you enter all the debits, and the other page you enter all the credits. And then at the bottom of the page you can keep a running tally of what accounts you've got. And as you go, you can just keep on adding up and down. And then on top of the page you carry forward the amounts in the previous pages. So and then you add up all the numbers down here as you go, and here's all the intermediate deletions or additions to keep the current total at the bottom. So VisiCalc used that same metaphor. So the designer decided to use the ledger sheet as a metaphor, and by doing that, because his target end users were accountants, so he used a tool or a metaphor they're already very familiar with, and it made it very, very easy for them to learn how to use technology. And of course, at those times, many accountants were people who had not used computers before as well. So these people were going from paper-based accounts over to digital accounts, and in many cases using the Apple IIe or for the first time. And the key that they added, though, was this ability to put formulas in the cells, and that was the real killer for the app for the accountants. Was that now no longer did they have to add by hand; they could create their accounts, and then they could put numbers into the accounts whenever they want to, and it automatically would tally things up. And also let accountants create sheets of formulas. So if you had an equation for a mortgage or for some calculation of some sale price, then you could go in and you could use VisiCalc to automatically calculate that for you as well. So it was very big successful. So the reason why it was very good was it was very simple and clear and obvious for users how to use. It also replaced this thing that was very tedious for them, which was calculating the same calculations over and over again. And it capitalized on their familiarity with ledger sheets, so the target end users already knew ledger sheets and went on again. Another classic was the Star Office interface, and this was developed at Xerox PARC, and the target end users again were business managers, because Xerox was in the business of making tools for businesses. And they also wanted to make it much simpler and easier to use for these managers who, again, weren't familiar with computers. So this is the Star interface. So from this interface, what do you think makes it so good for managers to use? What's the metaphor that they're using here? Yeah, it's a desktop metaphor, that's right. So you can see, for example, here's an in tray and an out tray. And so when they got messages, they put in the in tray. When they want to send messages, they put them to the out tray, and they'll hit the send and they send the messages. So, of course, in those days, managers would have an in tray and an out tray on their desk. They'd also have pieces of papers. Here are a piece of papers. They'd also have folders. So here are folders, and the like.
Stack as well.
Yeah. Yep, that's right. So they can stack up on it as well. So the benefits of having good interface metaphor is it makes learning new systems very, very easy, and it helps people understand your underlying conceptual model. So in this case, the metaphor is a desktop, and so as a designer, if you want to design new tools, so say you want to add a calculator to this, then probably what you want to do is you want to make it look like a desktop calculator, or they added the clock, so you've got a clock here that looks like a desktop clock. Or if you want to have some other application, maybe a drawing application, then maybe what you do is you try and make it look like a blotting pad and make it like a drawing application. So once you've got a good metaphor, it helps you, it eases the design process because it means that you now can design to be consistent with that metaphor. However, there are some problems with metaphor design. So can you think of any problems that might be designing with metaphors? Yeah, that could be one problem. Yeah.
They might suggest more than what they're actually capable of doing. The metaphor might be able to suggest that it does a certain extent of functionality, whereas what you do might not actually do that.
What's an example of that? Do you have any examples? That's a good point, though. Okay. Well, one example might be with the iPhone, you've got this new voice interface, Siri, and I guess Android, they've got a similar application. So with Siri, you can ask a question using your natural voice, and then it translates it to natural language, and it sends a query out and replies to you. People using that might assume that Siri is really intelligent because it speaks the answer back to you, and it gives the answer back in plain text. And normally, we assume that people can only do that when they've reached a certain level of intelligence. But in fact, Siri is just really a glorified search engine, and so it doesn't have any intelligence on the back end. But you may assume that because it's showing some intelligent behaviors, and that may get you in trouble. Like you might ask Siri for Siri's opinion on a certain movie, or you might ask Siri for important life decisions, like should I have this treatment for cancer? Because you assume that because Siri can guide you to the nearest gas station, that it's also good for asking those types of questions as well. But in fact, it's not.
I think because I've named it as well, it's like almost a person.
Yeah, they're deliberately trying to make it like a person and personalize it as well.
So that sort of implies that it might be.
Yes, yeah, sure. So there could be other things as well. So sometimes you can break conventional cultural rules. So the desktop metaphor, as part of the desktop metaphor, they oftentimes have a recycle bin on the desktop. But in a real office, you never put your rubbish bin on the desktop, right? So you're breaking the metaphor. It also constrains designers in how they conceptualize a problem, or it may conflict with certain design principles where, because you're adopting a certain design metaphor, you have to design everything to be like this. It may not work. So you can also inadvertently use bad designs as well. So let me give you an idea of that. So this is Microsoft Bob. Has any of you seen Bob before? Maybe it's a little before your time, but have you seen it?
Seen that dog.
Okay.
Yeah.
So Microsoft Bob, actually, this was a pet project of the woman that became Bill Gates' wife, Melinda Gates, but she was the project manager of it before she married Bill Gates. And the idea was a good idea in general. The idea was that in the late or mid-90s, Windows 3.1 had just come out. Windows 95 was about to come out, sorry. And Windows 95 actually was probably the first time people were actually going to start using Windows widespread. But it was actually took a bit of a learning curve to learn how to use Windows. So Melinda Gates had the idea, why don't we have a skin on top of Windows that hides the complexity, makes it really, really easy, and has a visual metaphor for doing everything. So and then you'd have this assistant, this dog here, that would guide you through things. And the idea was this is supposed to be a learning tool that would teach you how to use a computer, and then it would graduate you to the point where you could start using fully fledged Windows 95. So this is what it looked like. You had a number of different rooms in the house, and then each room had different functionality. So here's the dog, and the dog says Nathan to start a program. Just click on it. So I can click on different things. So here's my calendar, for example. So I click on this, then it opens up the calendar application. If I click on the clock, it opens up the clock application. This is the portal to the World Wide Web. This is my address book, and this is my email book. This money stack here. This is my finance program. So I can click on that, go to Microsoft Money. And this is a photo album. So I click on this and go to Pictures and Photo Album. I've got a video of it working actually. So
I can't believe it didn't take off.
well, I'll show you the video and you can see what you think. In fact, you can still use Bob. You can download the. It kind of crashed in the market, failed the market after they, they sold 1 million copies or something. But for Microsoft, that was a failure. So then they released the application on the web for free, so you can download it and you can still run it on your. It only runs on Windows, of course, but you can run it on your PC. But here's a video of it, and I would normally have it running, but I can't on the Mac. It will work. So here's Bob working on Windows XP. Oops. But, so and then you type in your password, and it opens the door. And the dog goes inside the house. Here's the Bob interface. And then you can type different things. So this is opening up Firefox. So now it'll open up the Firefox browser. Hopefully it goes and shows other things as well. Sorry, the resolution's too bad to see what he's doing, but you can get the idea. Yeah, that's all good. Yeah. So he'll go back in a minute to that thing. Now goes back to the interface. You can also go to different rooms. And it's quit. Okay, that's great. So that gives you a brief snapshot of it working. So what can you think might be some of the problems with using something like Bob?
Quite cartoony. I don't think any professionals might use it because it's just the nature of it.
Mm-hmm. Yeah, that's definitely one problem. And it wasn't, to be fair, it wasn't targeted towards professionals, it was targeted towards new computer users, but it is very cartoony, so that's definitely a problem. What other problems can you see?
It's not really a good use of space, like a lot of space is taken up simulating a room.
Right.
As opposed to displaying.
Yeah. What else would be a problem?
The location of items. Some people arrange the things in their house differently to others.
They do, and you can arrange things on the shelves here. So you can, there's a couple of other problems. So one is you saw it when I opened the Firefox interface. So here's the nice Bob home interface. When Firefox opened up, it went immediately to the Firefox interface with the Windows, well in this case XP, but it would be Windows 95 GUI around Firefox, with the and now the point of this was to in fact shield people from that interface, so they didn't do it. But now, as soon as they click on one of these objects, it then opens up the browser or whatever, and it looks like it's in Windows. So now you've still got you have to teach people how to use put-on menus and that type of stuff as well. So it kind of breaks the metaphor. The other issue is the dog character. So I guess some of you may be old enough to remember Microsoft Clippy from the Office, and what people would do quickly is turn it off because it got really annoying. and the dog was the same. It would basically it would have a dialogue with you and say, oh, I see you're trying to do so and so. Do you want me to help you? And it got really annoying really quickly. And perhaps the main problem is that there was no transfer of learning. So in this case, the underlying metaphor is a house metaphor. You know, you've got your house, and you've got these objects in the house that do special things. But the goal of this was to teach people how to use Windows, and Microsoft Windows isn't built with the house metaphor. So, you know.
But when you say the goal is also to give people the confidence to use the computer.
Right, yeah, certainly. Yeah, no, well, it was to get people to use the computer, but hopefully get to transition away from this onto Windows, because this doesn't provide you with all of the functionality that Windows provide. Like you can't copy files, and you can't create your own folders and arrange things in folders and type of stuff. So that was part of the issue, is that people learn how to use Bob, but once they learn how to use Bob and they get really comfortable with that, if they went to a Windows machine that didn't have Bob on it, they were kind of back to square one again, because they didn't learn how to create folders or Windows as well. So in some ways it was kind of crippled learning in some ways. So there were lots of problems with the interface, and needless to say, it kind of died a death in the market. Another thing is that as users become familiar with the technology, the metaphor is no longer needed. So this is the desktop evolution over time. So the first desktops were very much desktop metaphor, and then with Windows 95, you see it becoming a little different. You don't necessarily have in train out trays, things like that. And then with Windows Vista, you can actually have this 3D Windows metaphor going on now. And as I said, I should have a screenshot of it, but the new Windows 8 Metro interface completely breaks the desktop metaphor. It's no longer there at all again. In fact, I think what's happening with Windows Metro is you're seeing people who are using the phone, they're using design ideas from a touch phone to inform the interface design. So I think what's happening is that they're assuming that people have learned how to use their smartphone, and they may they want to be able to use some of the smartphone and UI techniques on the desktop, and so they have a desktop interface that looks like the phone interface. Transfer it back. And another example is the mouse, for that matter. So last week I showed you the video of Kevin Costner advertising the Apple Lisa, and he was holding his mouse kind of sideways like this with his left, in a very awkward style, because that was one of the first times he didn't know how to use a mouse. And now, of course, if you have a something that looks like a mouse beside a screen, then people are very comfortable with using it. You have to teach them how to use a mouse.
With that Metro and Windows Phone, that's quite good what they've done, because it's make it simple, like a lot of skill transference.
Yeah.
They'll be more happy to use this device because it's familiar.
It could be though, but it'd be interesting to see what the feedback is. So I used it for a little bit, and I had a hard time imagining how I could browse my files. But I only used it for 2 minutes. But I mean, it was very beautiful, and it was very nice to swipe through, and everything was great. But I couldn't imagine how I could browse and find files. I also noticed myself, and probably because I'm lazy, but when I moved from the I still have trouble now using the latest version of Word, so Word 2010, because they now have this ribbon interface on top of it. And I have a really hard time formatting pages, because I'm used to using Word 2007 and all stuff. Yeah. So it's the same. So it's the same there. As you get used to using a certain thing, and then Microsoft have now created this new interface, this new metaphor, and for some people who are older like myself, it becomes an obstacle to use in some ways.
It'd be interesting to see new users who have not looked at the older Word program, pick this one up straight away and see if they can get a good mental model of where everything is.
Yeah, they may be able to use it faster. I mean, I think So
because I think like people like us, it's almost plague now. Like we're going to be able to get rid of the drop-down menu system out of our heads. Well, I don't think I can.
And of course, sometimes what they do is say interface designers allow you to revert back to the old interface anyway. So
actually, I've done that in Metro as well.
Yeah. So that makes it. And it was the same with Vista. You could make it look more like. It seemed like XP was really popular, and then people were actually reluctant to swap over to Vista, but you can actually make it look like XP if you want to. So there's some things you think about when you're designing metaphors, and you have to think about the metaphor in the form. So for example, you can have a 1D metaphor, which is text. So in the Fitbit here, they basically have a 1D text window they can show stuff. You can have 2D design, which is really about designing the 2D visual metaphors, and I guess that's a little bit what Christoph was talking about. You can go to 3D and you start thinking about tangible metaphors. So here's some people who, it's an artwork, but they basically copied game art. So they have, these are the types of boxes you'd see in Quake or some sort of game put into the real world. And then you can also think about 4D design metaphors, which is more about what we do with interaction design, where you're thinking not only about the design of the technology, but also the user's behavior, time, and social practice and social use. So here's a guy who's walking around carrying a giant axe on his back that you'd see in a game, like World of Warcraft or something. But you've got to think, well, how are people going to respond to him, around him, when he's walking around the real world carrying this giant axe on his back? A nice example of metaphor is digital cameras. So here's the Canon EOS digital camera. And this is one of the first digital cameras that were all digital, but you can see it looks almost exactly the same as the older Canon film cameras. In fact, I had a Canon EOS Rebel, I think it was called, which was a film camera that looked almost exactly the same as this. And there's no reason now to make digital cameras look like the old physical cameras. In fact, this, my iPhone has a 4 megapixel sensor in it, and it is the same or bigger as the first SLR digital sensors in phones now. But obviously the form factor of my iPhone is very different from
The optics.
Oh yeah, sure, of course the optics is different. Yeah. So it's interesting to look at a digital camera like this and see how they've tried to copy the same interface that you'd have in a film camera. So they have a lot of buttons. They have an LCD display that shows some of the things you have in a film camera. They have a look-through viewfinder that shows the same feedback you get from a film camera as well. And they also have designed it so you can hold it in the same way as the film camera. So they keep that same interface metaphor. I dare say that probably in 20 years' time, once the current generation of people have kind of passed on or gone on, then the new digital cameras will look nothing like the old film cameras at all. You'll have, things the size of your thumb that'll be able to take 20 megapixel or 40 megapixel photographs, and with amazing optics. And
optics aren't really producing in size. Right. And at least none never go the same way.
Sure, yeah.
Things are they just completely dispel the need for them. Then you run pixel camera.
Well, yeah, that's true. And well, you've got these new liquid lenses you can put into cell phones that don't need the glass lenses anymore. So it's a really interesting interaction between the material, the form, and the metaphor you're trying to design as well. So in this case, there's a person who's got a wooden brick, and he's done some things you wouldn't expect. So when you've got a piece of wooden brick, you don't expect it to show an LCD panel display on it. Mark Weisner, who's very famous in ubiquitous computing, he's dead now, but he said that the most profound technologies are those that disappear. And that might be true, and that was the ubiquitous computing mantra, was that we should have technology that disappears into the fabric of our lives. But the challenge for that is when the technology disappears, it's very hard to design for the technology because you can no longer see it again. So here's a comic that talks about the problems of the invisible computer. So the guy says, well, obviously the coffee pot at home tried to tell my PDA to buy some Colombian beans on the way home, but the car overheard the message and took me to command to turn for the grocery store right away. So somehow the coffee machine caused him to have an accident because it told his car navigation system how to drive. So you can imagine in the future, if you've got invisible computers, there could be some interesting things happening with the design around those things. So in summary, in order to be able to do good interface interaction design, you need to have a good understanding of the problem space, and you need to build a conceptual model that provides a high-level description of the product, and then you need to design the interface metaphor around that, and then somehow communicate that to people as well. So what I want to talk about now for the second part is about affordances, and we'll talk about it now, and we'll also talk more about it in a few weeks when we start talking more about physical design as well. But just to have a small break, I thought what I could do is return back to the Fitbit that I've got. So I said this was a pedometer, but the interesting thing is what happens when you go to their their website, which somewhere I've got loaded up here. Not there. Let's see. Not there either. It's here. Well, let me just log on again so you can see. So here's the Fitbit site. And as I said, the main piece of the interesting thing was the technology around the website. So you've got this small device that you can measure your steps, and you can measure your altitude, and in some ways it's like the Nike Plus. But then what you do is you create your own, and this is where the real value comes, is the site here. So the website here lets you log your activity. So apparently today I've taken 2,000 steps, I've burnt this number of calories. If I go back to yesterday, I was a bit more active, 7,000 steps, walked 6 kilometers apparently, burned 2,500 calories, and then they have a graph here over time to show. So, well, in the evening I walked to the store, so it's a walk in the evening. This is lunch break. Here, I drove my car to work, so there wasn't much activity there, but it was I had to walk to a meeting around that time. And then you can also look at the calories burned over time as well. And and it tells you how much of your day was active versus sedentary. So almost 20 hours I was sitting around doing nothing, and then just a few hours I was actually doing activity. Yeah. I haven't been doing the food thing yet, but I can do that. But and the sleep thing didn't work out very well. It comes with a wristband. You're supposed to put this on. I somehow lost the wristband, so I've got to get a new one. But apparently yesterday I only slept for 20 minutes, which is not quite accurate. But normally you would it would show you your sleep pattern and how much time it took you to go to sleep and how much time you were awake. So that doesn't work out. Yeah, and I can log my mood down here. I think some of the value though also comes when you you start interacting with your friends. So when I've got my friends involved here, then I can also join up with them and see their activity as well. And you can also create your own log here where you enter the food you're eating, and it'll tell you the calories you're eating as well. I haven't been doing that, but I should probably do that. And you can create a journal, a sleep journal, some activity journal. So you can see that the technology itself is pretty small, the physical technology, but around that they've built a whole user experience that adds a lot of value. And in fact, no doubt you could potentially use some other device to capture your amount of footfalls and everything, and somehow input that into their system and do the same thing also. But it's mainly the web experience that provides a good experience. If I log out, then it's interesting also to see how they market or how they sell Fitbit, because it's, so if I go to the main this home site here, so this is how they sell to you. So basically the company sells two things. They sell the Fitbit, this little thing here you can wear. They also sell a set of scales that you can weigh yourself on, and the scales will wirelessly update your weight back into this log thing as well. So if I spent another $100 or so, I could get the scales here that would then fit into the thing, and also calculate the body mass index.
The photo of the person participating had something in the...
Yeah, that's the wristband I lost. So you're supposed to, when you go to sleep, you have a little wristband you wear. You're supposed to stick this on your wrist, and then you sleep, and then it measures the acceleration of your hand. And presumably, if you, well, I guess it can measure somehow when you get relaxed, and when you get really relaxed, it assumes you're asleep. And if I start moving my hand around, then it assumes I'm waking up in my sleep. So I don't know. Obviously, it's probably not as accurate as wearing an EEG machine or something that measures your brain patterns, but it provides some activity anyway. And it's interesting to watch how they market it with the video too. You should watch this with
Some
the
see
idea
a
of
dash to work.
prototyping as well.
We see a path to fitness. Some see a day filled with challenges. We see small steps that lead to big results. Some see a flight of stairs. We see the chance to scale a mountain. Some see a rumpled bed. We see the opportunity for a good night's sleep. See the possibilities of a healthier you by tracking your daily activities with Fitbit, because the more you know, the more motivated you'll be. Your data uploads wirelessly to Fitbit.com, where you can easily track your progress, compete with others, and log food, weight, and more. Take a healthy step forward with tiny, comfortable, discreet Fitbit, because we see every step as a step toward better fitness.
Okay, so from that video, what's the message that they're trying to convey, do you think?
They said the more you know, the easier it is.
Yeah. And do you think that's true? Do you think, in your own experiences?
Those types of feedback play a part.
Yeah.
Like, I mean, you know, in terms of like tidying your room or something like that, the first 5 minutes is always the hardest, like just starting. And so in that respect, you know, kind of seeing when you see your progress, you're like, oh, actually, I'm halfway through and I've only just got to sweep the floor.
Right, yeah.
So yeah, I think it does work like that. It could be both, and go both ways. It could be both positive and negative feedback. So if they have it for a week or a couple of weeks and they look and they see they haven't really done much, it might not motivate them to do any more.
Yeah, that's true. It could be, yeah. Well, I mean, I think well, I've only used it for 3 days, but I've noticed myself it's very interesting. I just said normal activity yesterday. I didn't realize that by doing that I was, had walked 7,000 steps. I'm not 100% sure how accurate it is, but I'm sure it's accurate to plus or minus 5 or 10% or whatever. And books say that you're supposed to be doing 10,000 steps a day to be able to stay active. And so without doing anything really, I was doing 7,000. If I'd gone for a half-hour walk at lunchtime, I would have pushed it to 10,000. So that motivates me a bit more to be a bit more accurate. And I think also that I didn't show, but it's the opportunity to set your own goals as well. So if I can edit my, I can go into my account here, and if
so who owns the information?
they do, which is also interesting as well, isn't it? Yeah. Oops. I don't have to type that again. Well, I mean, I guess there's as far as I can tell, there's no way for me to download the information to my machine. So, which is an interesting privacy issue, isn't it? So that if I decided, I'm done with Fitbit, I want to go to some other device, but I'd still like to have this history, or if I would go to my doctor and say, here's my medical data.
You should be able to download your statistics.
You should be able to, but as far as I can tell, but I haven't played very much. Maybe you can, but you can. So you can set you can find out your body mass index here. You can also set goals. So I put in yesterday a goal to lose some weight, to just as a test to say, well, I want to lose some weight to get to 70 kilos by June. So I can edit this goal here. I can say, well, I'd like to lose a lot of weight. So maybe I think I need to get down to 60 kilos, and then go next. And so I can edit this, and so I wanted the hard program where I want to lose a kilo a week. So they say, well, if I do that, then all I'm allowed to eat in that case is 1,100 calories, which I guess is probably one McDonald's meal a day or something. Which it is, but yeah.
Suggesting that people can lose X amount of weight and give them plans which might actually not be healthy.
Yeah. So I'm sure there's some terms of use here where it says that this is using conjunction with advice from your doctor and blah blah blah, whatever else. But yeah. So anyway, that's the goal. And if I was logging my food, then I could have lunch and I would look on the calories per serving and log it here, and it would tell me how much I've eaten today and how much I can still eat. Does that matter? So that's Fitbit, but the interesting thing about Fitbit, again, from a design perspective, is how they have taken a small piece of physical technology, designed a user experience around it, and then how they market it with the video and other things as well. As part of the marketing is motivation, like you said, so being able to motivate because you can see how much activity you yourself and how close you are to getting to different goals. Like if I'd known, well, I can push this in, it said so far I've done 2,000 steps, which is not very much. So if I had a goal to do 10,000, then I said, well, I better go and do an hour walk or something to push that up. But part of the other motivation is well, you can get little achievement badges. So I got my little badge for doing 5,000 steps in one day, so that's great. And you can also, I think the friends will be a big motivation as well. So I met with a guy from Industrial Research a little while ago, maybe a couple months ago, and Industrial Research are trying to get their staff to be healthier. So what they've done in Industrial Research is they've given pedometers to all the staff, not as sophisticated as Fitbit, but very simple pedometers. And then all the work teams are having competitions between the team to see how many steps they do in a certain period of time. So they'll have a competition where whichever team does the most steps in a week gets to have a pizza lunch together or something. Or whoever's the most, and the goal is to try and walk from New Zealand to England or something. So to do that is 2.5 million steps or something like that. So as a company, they're trying to walk all the way to. So it's kind of a motivational thing.
Dynamic, it's something similar to that, like the Mediterranean or something.
Yeah.
They go stuff like kilometers.
Yeah, and I guess part of the point is that if you have healthy staff, then presumably they require less health costs and things as well, and get more productive and stuff. But anyway, that's the Fitbit story. So going back to let's talk about affordances then. So affordances is the quality of an object. Is a few definitions. I'll talk about a few of them, but basically it's the quality of an object that allows an action relationship with an actor. So what that basically means, it's the shape of an object that allows you to do a certain thing. So for example, what does this thing do? Well, it's a chair, obviously. So the shape of a chair allows you to sit on it if you want to. And toothbrush, so the shape of the toothbrush allows you to put in your mouth and to brush your teeth. And this affords standing. It's a Segway. It has a platform you can stand on it. This user interface. So those are all physical objects. But the same idea about affordances can also transfer over to the digital domain as well, but in a subtle way. I'll talk more about that in a minute. So this map, this is the Flickr interface for geotagging photographs. So the map interface affords clicking on the map and locating or tagging photographs on the map. However, sometimes you have problems with digital interfaces as well, like this one. So what does this let you do? When you look at this, you've got no idea what the affordances of this really are. So I want to talk about the affordance design and how, if you do it well, the way you design objects can actually help people in using them. If you do it poorly, then you can actually have problems in design. So affordance is actually a technical term that comes from psychology. Does anybody know about J.J. Gibson? So J.J. Gibson was a ecological psychologist, and his basic idea was that what he talks about here, he says that ecologists use the concept of a niche, and they say that certain species of animals utilize certain niches in the environment to survive. So, the niche suggests, he says, I suggest that a niche is a set of affordances. A natural environment offers many ways of life, and a way of life is a set of affordances that utilizes. So his idea was that the object itself had certain innate properties that allowed you to use it in certain ways.
Can you explain? Can you say what affordance means?
Well, that's his definition. His definition is the. Well, this is his definition of affordance actually. So his definition here is So his definition is an affordance is an action possibility available in the environment to an individual. That's a lot of big words, but the easy way to think about it is this: with the chair, for example, the chair is shaped, got an L shape, so that provides an action possibility of sitting down. So one of the affordances of a chair would be for sitting. So the key point of this, the spelling mistake, is that the affordance is independent of the individual's ability to perceive the possibility. So if you had a chair in a room and you had a blind person in the room, and the blind person couldn't see the chair, the blind person could still sit in the chair because the chair afforded the possibility of sitting. It was shaped and it could sit in the way. Does that kind of make sense to you?
Yeah.
I'd
say perceived as in a wider sense there as well. Whether to comprehend it.
Yeah, sure, yeah, and we'll talk about that. Yeah, we'll talk about that more in a second. So, but the affordance generally depends upon the context, and it also depends upon the capabilities of the actor or the person that's using the technology. So, for example, here's a window, and the window affords looking through it and to seeing the other side of the world. And whether or not you've got somebody who can actually, like again, the blind person, you have a blind person in a room, that doesn't prevent the window allowing somebody to look through it. So there are two parts here. One is having a capable actor, and then the other part is perception. And this person said that their definition can be confusing. So, for example, is the affordance the chair provides for sitting a property of the chair, or is it property of the person? Humans have shaped in a certain way, and because the way we shaped, we can sit on the chair. If we were an insect shape, maybe we couldn't sit on the chair anymore because of our body shape. So is the affordance a property of the shape of the object, or is it a property of us, or is it something else? So the notion of affordance is actually a bit poorly defined.
Well, if you have an egocentric worldview, it's not a problem.
Yeah,
you just define everything in terms of how it's useful to you.
That's true. Yeah. So Don Norman, who's a very famous interface designer, he said that there's this problem with the concept of affordance, and he wanted to modify it a little bit. And he modified it, and he wrote this book called The Design of Everyday Things, which is here, and also this other book called The Psychology of Everyday Things. And he had this partner, Jacob Nielson, and they formed this company, Nielson Norman. And what they said is that rather than talk about the innate affordance of the object, what you should talk about is the perceived and actual properties of the thing. So when I look at a chair, I know I can sit on it because of the way it's shaped and because of my past experience. I could also look at other things like a rock or a log or other pieces, and I could know I could sit on those things as well. And that's because I can perceive that in the object.
Things like mode blindness or something, cover the plane dozens.
Well, that's what we'll talk about. So the challenge with that is that sometimes you can't perceive the affordances. Mm-hmm. So sometimes your user interface may have properties that you cannot perceive, and that becomes a problem. So, for example, in the iPhone, there's a pinch to zoom, but that's not obvious from looking at the iPhone interface or looking at a picture for that matter. So now we're moving away from perceived affordance to other things. So Jacob Nielsen wrote this other quote about how that the concept of affordance is caught on, but perhaps not always with true understanding. And he said in his case, perhaps instead of using the word affordance, what he should use is the word perceived affordance, because as designers, you care more about what the user perceives than what is actually true. So when you're designing something, what you're trying to do is design something for somebody to perceive it and see it, and whether or not the user can actually perceive that. So the main thing from a design perspective is to think about the perceived affordances, and so you can build this perception framework here, and this is kind of a 2x2 grid. So on one side you've got whether or not the object can act in a certain way. So whether with a chair, whether or not you can sit on it or not. And on the other side, whether or not you can perceive that affordance or not. And so if you don't perceive the affordance, and if you can't perform the action, then the object is useless, basically. But it could be that you could think you perceive an affordance, but actually that affordance isn't there, and that's a false affordance. It could be that the affordance is there, but you can't perceive it, and that's a hidden affordance. And then the ideal goal is the one at the top here. So I'll show a couple of examples of these, and you can see yourself. So this is what you want to have. You want a good user interface design tells the person how to use the technology, and it shows the action possible. So, well, I didn't bring it, but if I brought a hammer with me, the hammer is a good example of that. When you have a hammer, it's pretty obvious what end you hit with and what end you hold because of the shape of the hammer. And the nature of the handle suggests that you can hold it, and it shows the action possibilities.
I wonder if conceived is a better way of looking at it.
And perceived?
Yeah.
Could be. Well, it's conceived in terms of you designing it, but it's perceived in terms of the person maybe seeing it. So here's the door handle, for example. So in this case, the door handle, it shows you how to use it. You're supposed to pull down and turn it because of the way it's shaped. But sometimes, I don't know if you've had this experience, but I've had the experience where you go to a bank or something, they've got lovely glass doors, and they have a flat bar. And when you see that, you're not sure if you're supposed to push against it or pull it or whatever else. And so that's an example of a false affordance, in that the action possibility is there. Sorry, it should be hidden affordance. The action possibility is there, but you're not quite sure how to use the door. So if we go forward to this one here, a false affordance, a good example of that is this handle here. So this is a doorknob, but the knob here, like in this case, the doorknob you can turn, but in this case this is a pull knob. So because of the shape of the knob, it does suggest turning, but in this case it doesn't turn, so it's a false affordance. And then you have a hidden affordance where the action is possible, but you can't perceive the action necessarily because it's hidden. So here, for example, this is a door. It could be a door, but there's no door handle or anything here, so you don't know how to open it or not. So it's a false affordance. And then there's the case where you've got, where you can't perceive the affordance and you can't act on it, so the object's kind of useless. So that's a useful a table to keep in mind when you start designing things, as you want to think about when my user interface design, what perceived affordances am I showing people? Like for example, I think I've got a couple of, I deleted it. Oh, okay, let's see what the next slide says. Okay, and then more recently, Ho and McGreen have talked about how the concept of affordance needs to be developed more specifically. So in Gibson's world, the affordance was innate to the object, but in Norman's world, the affordance is a function of perception, and what they are trying to say is there should be some gradation between that, where you incorporate varying degrees of affordances. So some objects support some things a certain amount. So you could sit on a certain object, but you may not want to. Like you've got an exercise ball. It doesn't. It kind of affords sitting, so you can sit on it, but you've got to keep on adjusting your balance to stay seated. And so they talk about how that what we want to do now from a design perspective is adopt a more semiotic approach and look at the process of affordances rather than a strict objects affordances or not.
Did you say process?
Yeah. Yeah. So one of the other interesting things, though, is to think about what's called a signifier. And so this is a discrete unit that signifies how something should be used. Sometimes one way is I found this quote which I thought was really interesting. It says that we're all detectives searching for clues to enable us to function in the complex world, whether it's flags waving in the winds, the difference between empty or crowded train platforms, or the desire lines illustrated by footprints in fields that suggest paths to follow. We search for significant signs in the world that offer guidance. So as designers, you can think about how you can design experiences that give those signs. A typical way is, when you, outside the HIT lab, for example, if you look at the patch of grass on the HIT lab, you'll see there's a patch of dirt that goes diagonally across the grass, the walkway from the corner there to the lab. Because people are basically lazy, and rather than walking on the footpath, so they go down this way. So that basically is an example of a signifier where it shows that, well, here's a shortcut path you can take. And if you imagine a huge big field with that type of path across it, or in farms they've got goat tracks, things like that, they're things that are naturally formed over time with use that show you how to get to different places more quickly. And it could be the same for both of us in the design work. There could be certain types of ways to design things that provide these signifiers. So, for example, here's a stop sign, and that same stop sign color, text, symbol is used across different cultures. So, I can't read this, but by knowing it's an octagonal red sign, I'm pretty sure it means stop. And similarly, these are Arabic or so forth. Here's interesting signifier. So this is a call button for an apartment, but in order to tell people that this is the speaker and this is the microphone, they drew this little line around it like a phone, and they also put a little phone button there. So you dial a person's apartment, you push this button, and it's like you're picking up a handset, and then you can talk on there and listen from here, and then you hang up from over here. So it's a very simple design change, just putting this engraving in the metal, but it easily conveys where you're supposed to listen and where you're supposed to talk to. So from a design perspective, you can think about, and again, this relates a little bit back to affordances in that this metal box affords listening and speaking, but in order to make it real or make it easier to use, they put this on there to enhance the perceived affordances and make it more obvious to the user. So that's the main slides today. I wanted to also just briefly, to end the lecture, talk about processing. I guess by now you've spent a little bit of time using processing. How are you finding it? Is it pretty easy to use?
Yeah.
Okay, that's good. So I wanted to show you. I'll put this presentation up on the web, but I want to show you a nice presentation of a designer who's been using processing, and I can find it. This one here. It's quite a long presentation, and so I'll put the whole thing on the web, and you can see. But this is a Polish designer named Marcin Ignac, and the presentation was Sketching in Code, and then basically the subtitle is How He is Processing to Do Prototyping in Almost Every Project. So he's doing some really interesting designs, and I'll skip through a few of them, and then I'll put some of these on the web. So basically, he talks about his life a little bit and how he's a programmer, designer, and artist. There he is right there. And he gives an introduction to processing, and I think most of you know this already. You've got the visual design tool. You can do simple things with that. It's a programming language. You can create your own classes, so it's extensible. You can use it from within Eclipse, and I guess have you been using it within Eclipse at all? Okay, great. Yeah. So, and then there's this. I don't know if you've been yet, but there's a website called openprocessing.org. Has anybody been there? Well, let me take you there. Let's see if I can show you that. This is the Fitbit site, so that's where I was trying to go before. And this is, okay, not what I want to show you. I can delete that. No, not that one. Must be the last one. Aha. Okay, so this is open processing, and you can go to the site. This is basically a website where people can share their processing sketches. Hey, come in. We're just finishing a class, but you're more than welcome to join. Got 10 minutes left. So this is open processing, and if you're interested in artistic applications of processing, I highly recommend going here. So basically, what they do is they do little design contests, but then they show favorite designs. So, for example, you can browse here the all-time favorites. These are designs that mostly just run on the browser, so they're not interacting with hardware at all. But so you've got a design like this, which is doing kind of a soap bubble effect, and they show that working. But most the best part of it is that you can scroll down at the bottom here, and you can this is the sketch running, but you can also click on this, and it provides all the source code for that as well. So the processing has a really great community. This was kind of a fun one I looked at too. And then some quite amazing things with very short amounts of code. So there's code here. So here's basically falling triangles. But you can move the mouse around, and you can bounce objects off the triangles off the mouse, and then it fills them in to be solid colors. Yeah, but that's all just in that little piece of code there. So if you want to have some insight into more artistic applications of processing, you can try different And again, I'll post the link to Open Processing while you're there as well. And okay, so this is another one that lets you change the visual effect of. So you're basically dragging stuff around with your mouse. You can increase the thickness of these lines. Some pretty cool visual effects. So anyway, I know in the labs you've been doing some very basic processing, so maybe it's time to move on to some of the more advanced ones that things like this afford. So that's the processing. Of course, you all know hopefully processing.org, which is the basic start point. There are also other libraries you can load in as well. So have you tried that yet with the labs, loading other libraries? So you can load in 3D graphics libraries, you can load in libraries for Arduino, other different visual libraries as well, physics and the like. Processing is also cross-platform, so if you haven't already, you can look at the Android version that lets you build Android apps that run processing. And there is the JavaScript that lets you run in other technologies like HTML5 or WebGL as well. So that's the basic processing community. I want to touch on a couple of projects he's done so you can see. So he's basically an artist, so here's some of the sketching work he's done before. And then he starts doing interactive media work as well. So one of the first works he did was called That What Is the First. And it was a room, and in the room there was a projector set up and a camera, and then he used processing to track the person in the room. So processing also supports simple computer vision input. And then projected on the wall here was a picture of his mother. And as you walk closer to the picture, it aged back in time, so it got younger. So it's very simple, but very nice. And if I can find, here we go. So this is the video of that working. Okay. So this is mother on the wall, and now he's going to walk closer, and the photo is going to crossfade between younger pictures of his mother going in there. He used Flash for showing the picture of his mother, but he used processing to do all the image processing. And it's very simple, it's just background subtraction as you get, and you find the moving blob, and as you get closer, it makes it narrow. Yeah, it's very simple. So that's one of the first pieces he did. That's very, very simple. And so processing can be used for motion tracking. So in that case, he used the motion tracking there, and then he put it in an abandoned building to add some context, and then the picture of his mother there. Then he moved recently to Denmark a few years ago into the interaction design course, so pretty much what you're doing now. He did another project called Greetings Gestures, and that was kind of interesting. What he did was he took the Wii and Wiimote, and he had different people from different cultures greet each other. And so the Wii lets you capture gesture to a certain extent. So he took a Wii, and I think he had people also, well, I think she's wearing, or on her body somewhere, there's a second Wii. So, and it turns out, so you can capture the acceleration. So when I shake somebody's hand, it captures the acceleration. And there's a piece of software you use called Darwin Remote that captures that, and then you can read that data into processing and visualize it in different ways. And what he found was different cultures do different things. So in Korea, you generally bow, so there's not much activity. The US, you might do a lot of waving. In Denmark, it's this kind of cheek kissing. Then Italy, it's handshaking. India, you do the namaste gesture. So different cultures did different types of greeting gestures. So he took those data sets, and then he produced, he mapped them over 4D and produced these posters of the mappings. So you could take the X, Y, and Z and the roll, pitch, and yaw over time, and then map them into different types of posters. And so he made these different greeting posters like that, showing different cultures. So that was a static piece, but it was quite interesting design that he'd done. And one of the other pieces he did was to do a Wiimote 3D drawing piece. So and the Wiimote detects is a camera image sensor here that detects LEDs. So he put a little bit of breadboard together, put some LEDs up there, and then he used the processing to do 3D graphics based upon the position of the Wiimote. So you could basically sketch in space. So I can show you that working. So that's there's his Mac there. I'll go back in time. So he basically has, there's the Wiimote there, and as he moves it back and forward, it's just mapping the XYZ position to a cube location, and then you can also click the buttons to turn on and off the drawing, so it's drawing 3D. Have you done any 3D with processing yet? Maybe not. No, okay, that's okay. It supports 3D, and it's but yeah.
Limitations of OpenGL.
Yeah, so it depends on how they implement the browser, but yeah. So yeah, it's a simple drawing application he did, and then he used that to build. You can build monitoring shapes, like you can once you've got the path, you can put 3D spheres together and build 3D structures. And then he said, well, now I've got the models. What I can do is I can import them to different applications, and I can print them. So now he's printed the 3D output here as well. So with the Wiimote, you can create the 3D structure, and then you can print the 3D output and do basically computational 3D printing design. We'll talk about this a bit more in the coming weeks, but with processing, you can also connect to physical hardware. They haven't done that yet, have they? Or they've done that a little bit. Okay, so you've already connected up the Arduino to processing. Okay, so you can connect to hardware, and so he's done some work on controllers like that. So here's a little controller with Tetris, so you can push the buttons to make them rotate and that type of stuff as well. You can also connect over Wi-Fi as well. So you can connect from your processing. In this case, he's using an iPhone to paint on the screen. So there's a library called the Touch OSC. OSC stands for Open Sound Controller. So Open Sound Controller is an open source library for sending message processing between different devices. And so in this case, you can build a simple iPhone app that sends Open Sound Control messages over the Wi-Fi to your processing that listens to the messages and then responds to them as well. And so he left and he joined this company, and now in the company do some interesting projects, mostly VJing and event projects. So he has things here where visuals respond to the live music, and I'll show you a couple more videos as well. He's doing work on projection mapping, so you can project an image onto a surface, and if you know the orientation of the surface, you can make the projection mapping work correctly. So for example, he's projecting onto pipes here, and makes the occlusion look real, so you can make it look like the dots move behind the pipes. Then you can go into project onto sofas, onto cubes. So here's a cube, and then go out into the real world. So this is a warehouse, and they were going to do a dance party here. So he wanted to do something in the club. So he wanted to project onto these ventilation shafts. So he had to first of all find where the shafts were, map them, and then he could project a variety of different visual imagery onto the shafts there as well. So that's most of what I've got. Let me just show one or two more videos of what he's done, and then we can stop for today. But I'll put his the presentation on the side as well, and you can explore around his blog. It's really interesting. So let's see. Oh, here's his blog here. This is. This is the video showing the gestures application working. So here's taking the greeting gestures, and here is he's mapping those onto. It's a really bad video because he recorded with his iPhone, but he's basically mapping the data on in 3D or 4D over time as well. And then when he gets interesting mapping, he takes a screenshot and uses that to make the posters he's got as well. But from his blog, he had some interesting work he'd done in terms of spaces as well. So this is the mapping piece that I've shown you before in the club, in the gallery. And this is what he'd done on personal data. So he'd basically taken he'd taken information about your own personal data and mapped it onto different walls around you.
Dopóki to samo robię, nie? Ciąłem, malował, przyklejałem.
Nie tylko miętniczek.
There's a chair there, and I think click on the chair, and it takes your own personal background.
Czy coś porobię?
It shows the yeah, and then it maps onto the walls around you. So if I could take my Fitbit, for example, and how much walking I've done, it could map it onto stuff. Places here. And then this is some of the visuals he did for stage events. So they create very large LED screens, and then they are interactive, and they map to the audio here. So he built this interface here for mapping the sound onto different visuals as well. And that was all done in processing. So, yeah. Anyway, that's all we've got time for today. As I said, I'll put the slides up and I'll post the link up as well. I'd encourage you to go to the openprocessing.org site though and have a play with some of the different, they call them sketches, so some of the different sketches people have created. Some of them are really amazing. Oh, yep, I sure can. I'll just look at this one first and I'll look at the fourth one. This is a 3D jellyfish, apparently. Yeah. So you wanted to look at the fourth one along, which is this one here. This one. Okay. I don't know what it does, but we'll see. Looks like there's no mouse input. It's like it's automatically generating fringe interference patterns. It'd be good for clubbing, I guess, for trance music or something. Yeah. But again, it's a very simple amount of code, and I guess the basic rule is you put your sketch here, and then you have to provide all the source code, so you can then. I was playing with this one before; it was kind of interesting too. So this try to create a depth effect with light and dark shaded, and as you get further away, they got the blob's got more blurry focus and kind of a particle system going there as well. So when you come time to do the projects, hopefully this will give you some ideas or some source code that you can start using for some more interesting visual effects potentially as well. And I think they said there's 300,000 or 30,000. Let's see, there's 30,000 sketches you can look at. So lots of different code snippets.
Is this all like royalty-free stuff?
I think part of the requirement is that it's well, I don't know if what the terms of use are. You should probably look at it, but I think it's all Creative Commons. So I guess it means anybody can use it. If you start making money off it, I don't know what that means, but yeah, but you can certainly use it at will, and use it to. I've got fabric simulator. That's pretty cool. So I can start. I guess I can hit R to reset gravity and G to do something. It's running pretty fast, considering. So it's, yeah, it looks like I'm tearing it there. Yeah. Yeah. So.
Does it slow down itself or something?
Yeah. So I can tear a piece off like that, and then it's torn in two, and then it's got a physics model there, so it kind of floats around a little bit. Anyway, that might give you some inspiration, and then you can think. I mean, it'd be interesting to tie this in with some physical input devices. So if I've got a piece of cloth, and I tear or do something with the real cloth, the virtual cloth behaves in some way.
I just mapped MIDI interface device to processing.
Oh, you did?
Yeah. So
cool.
I can get like the velocity and stuff. Yeah. And now I've got like this turntable thing as well, which I'm trying to get that going as well. Well, you should think about, we talked today about affordances. You should think about the affordances and how that maps. Like,
maybe sliders map naturally to position, but they might not map to orientation. The turntable maps to orientation naturally. Like that. So, yeah. Great. So, are there any questions talked about today? So, we'll talk a bit more next week about more examples of design using processing and good design, and then also good luck with your assignment. If you have any questions about the assignment, then I'll be available all next week, and I can talk you through it. If possible, I think you should try and go this weekend and go down and try City View AR in the city, or if you can't go this weekend, go down during next week sometime. And Gun's got the devices you can use as well. Good, okay, well thanks for that. Now I'll see how I can stop the Camtasia working. No worries. Let's see if I can stop recording.